All right. So basically, this is just a full review of chapter 2. I don't know what's going on. All right, sorry about that, guys. I think I'm good now. All right. So state the domain and range of the relation, determine if the relation is a function. So if you recall, the domain is just the set of the x values. All right. Now I always try to tell kids put them in order. All right, from small to large. All right, not that it's a big deal if you don't, but all right, so -9, -3, -2, 0, 5. Now look, 5 is written twice, and then 11. Now if it's written twice, you don't have to write it twice, all right? The range are just the y values. So -18, -10, -9, 6, and 9. That's considered the range. Now the question is it a function? And the answer is not a function because the x values, 2 x values, are the same. So it's not a function, just a minor detail. Not a function.
Yeah, I was wondering how you can avoid that range.
All right.
So what they're saying is that this is
now again, this is called a mapping. Okay. All right. Sometimes in advanced math or before, you know, there was just different techniques of writing ordered pairs. This mapping was considered 1, but to write it as an ordered pair, it would be -3, 6, 9, 7, and 9 is also mapped to 8. All right, so again, it's already telling you the domain, which is kind of silly. And this is the range over here. And this would, again, not a function. All right, is everybody okay with that? Any questions? All right, let's check out graphing. All right, we've graphed this line a million times, so let's do it one more time. So -3y is equal to -2x plus 9, dividing by 3, or -3, I would say 2/3 x minus 3. All right, so from there we go down 3, and then we go up 2 and over 3. And of course, draw the line. All right, again, should be super easy. Anybody have any questions? All right, now we're going to do the inequality. All right, so again, subtracting 5x. Now don't forget, when we divide by -4, you change the inequality sign. So y less than 5/4 x plus 3. All right, so now plot a couple points. First thing is you go up 3. The next thing is we got to go up 5. 1, 2, 3, 4, 5. To the right 4. 1, 2, 3, 4. All right, now don't forget, as you're drawing the line, it's technically supposed to be a dotted line. All right, so I like doing it that way. No. So it's a dotted line. And then we say it's shaded less than. So it'll be everything below. All right, anybody want to speak up? Anybody have any questions?
Mr. Shaw?
Yes, sir. Good. Thank you for asking.
If the line's dotted or not.
Yeah, it is dotted.
No, but how do you know?
Oh, because, I'm sorry. Remember, greater than or equal to, less than or equal to, it's a dotted. I mean, it's a solid. Sorry about that.
Right. Thank
If
you.
it's greater than or less than, that's your dotted line. Anybody have any questions? Thank you very much for that. All right. Now here, all right, I want everybody to remember the absolute value graphs look like a V. And then we'll talk about the transformations. So inside it's going to be shifted to the right 4. Outside it's going to be down 2. And the number in front, we say, is your vertical stretch by 3. But technically it's by -3. But what I want you to remember about the negative is that just reflects it over x-axis. Okay, so again, we're just going to plot some points, and I'll show you what I want you to do. All right, so the first point, remember, is we say it's shifted to the right 4 and down 2. There's that point. All right, now the next point, instead of going to the right 1, right, and up 1, you go to the right 1, then you multiply going up 1 by -3. So instead of going up 1, you're going to go down 3. 1, 2, 3. All right, so sorry, I want to double check that. 1, 2, 3. Anybody have any questions with that point?
So, Mr. Stroud,
Yeah, good.
the -3 is like it's slope in a
Yeah,
way.
it's in a way it is. All right, but the better way to describe it would be the stretch. All right, and what I mean by that is 1. I'm going to go down here 3, and then I'll show you exactly what I mean. All right, so let's look at that now. All right, and what I'm going to do is I'm going to go ahead and graph that, and then I want to show you what the absolute value looks like. I mean, I know everybody knows, right, because we did this already, but generally the absolute value is 0, 0, 1, 1, left 1. So it looks like this. That would be the absolute value of x. Now what you're supposed to understand is that instead of going up 1 and over 1, it's technically up 3 and over 1. So whoever said it's like the slope, yes, you are correct. It's kind of like the slope. But remember, this vertical stretch of -3 works for all functions, whether it's a parabola, okay, whether it's a square root. There's all different functions that you're going to be learning to graph next year. And the transformations work the same. If you're inside the function, what I mean by inside is this. If you're inside the function, you shift left or right. If you're outside the function, you shift up or down. And this literally means you're multiplying the y by -3. All right, that's technically what that means. All right. So now let's look at the reflection, or let's look at the transformations here. I want everybody to say that we're shifting to the right, shift to the left, 1. Then we're going to shift down 3. And this time we say it's a vertical stretch of 2. All right, so generally you just need 3 points to plot. So again, the first point, shift left 1 and down 3. Okay. The next point, now instead of going over 1 and up 1, we're going to go over 1 and then multiply up 1 by 2, so it would be up 2 units. Right there. And then this point, left 1, up 2 also. Right? Now this is an inequality, all right, and it's supposed to be a dotted line. So I'm just going to make it a solid line and then make it dotted. All right. All right, so dotted.
Mr. Stroud?
Yep.
Why would it be a dotted line if it's a greater
Oh,
than or
wow. Thank you so much. It's not dotted. For some reason, I had it in my mind that it was not. Okay, so thank you for that. So what I'm going to do is, there we go. Now it's back to solid. Thank you very much. All right, so now we have to just remember that we're shading what? Shading less than, right? So that would be everything below the graph, which would be all of this. All right, guys. Everybody good? All right, now, this kind of was like the new topic. Okay, so I want to make sure everybody's paying attention on 7 and number 8. And essentially, I think the graphing the absolute values is new also. All right, but technically, this is one that a lot of kids have trouble with. All right, so what I want to do here now is I want to look at this, and I want to say we're graphing 2x, this piece, everything less than -1. So f of -1 would be -2 because I plugged -1 in. However, because there's no equal to sign under here, right, this is going to be an open circle. So I want everybody to go to -1 and go down -2. And now that's going to be an open circle. And then we want less than -1. So we're going to do f of -2. And that's -4. All right. So now we're going to plot the point -2, -4. -2, 1, 2, 3, 4. Okay. Then from there, I'm going to go ahead and draw the graph. All right, now that's the graph for everything less than -1. All right. Now, the next one, all right, the next one is graphing x plus 1 from -1 to 2. Again, that's a line, so I just really need 2 points. So I'm going to start at -1. When I plug -1 in, I get 0. And then if I plug the last point that's going to go in is 2, then that would be 3. All right. Now keep in mind, the first dot is solid because it's equal to, and the last point is an open circle because it's not equal to. All right, so now I'm going to graph these points. -1, 0 would be right there. And then we're going to graph this point, 2, 2, and up 3. Then what I'm going to do is I'm going to try to connect those. So that is that piece of the graph. That's why they call it a piecewise function a lot of times.
Mr. Stroud?
I'm listening.
I have a question on how you got 0 and 3 from that.
Okay, so what I did was I took this -1 and I plugged it in to the middle equation.
Oh, okay.
Right, and then I plugged 2 into the middle equation. And negative 1 plus 1 is that 0, and 2 plus 1 is that 3. Does that make sense?
Yes, that does. Thank you.
All right, so this is the first piece. This is the second piece. And now I'm going to do the third piece. Okay? So f of 2 is equal to 3. It's saying greater than 2, so I'm just going to do 3. That's also 3. Now they're both solid. So at 2, now what's nice? 1, 2, 3. It actually what? It actually filled in the hole. Does everybody see that? And then f of 3 is 3. 1, 2, 3. So the last piece of that is this. Right now, it's important in math. You're supposed to know that at this point, it is continuous. And at this point right here, it is not continuous. And you're going to spend a whole lot of time in calculus talking about that. All right, very good, very good. Anybody have any questions? All right, so I have another question here regarding the piecewise functions. All right, so again, let's look at the first piece is for everything less than negative 2. All right, so let's look at the first. So if I start at negative 2, I'm going to be 3. If I'm less than negative 2, it will also be negative 3. Now this one is an open circle, and this one is a solid dot. Right, so when I graph those, at negative 2, I'm going to be at negative 3. And then at negative 3, I'm going to be at negative 3. And I know that's just a horizontal line. All right. Now the next one is second piece. All right, so we want f of negative 2. And now I'm going to plug negative 2 in here. And the absolute value of negative 2 plus 1. Negative 2 plus 1 is negative 1. The absolute value of that is 1. Now, I want you to think about it for a second. So the absolute value is a v. And so I want to make sure it would be shifted to the left one. All right, so essentially what I'm trying to say is I'm going to plot a few more points just to make sure I see the graph properly. Because it's not a line, it's a v. So if I plug negative 1 in, I get 0. And if I plug 1 in, I get 2. And actually, I forgot 1 point. I forgot 0. So there you go. All right, so now I'm going to plot each one of these points. This one is a solid, 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 and open. All right, does anybody have any questions with that? It's not a line. That's why I didn't just use 2 points. So at negative 2, I'm at 1. At negative 1, I'm at 0. At 0, I'm at 1. And at 1, I'm at 2. All right, now you recognize the V. So your V goes like this. And then it goes like this.
Mr. Schraub,
Yep. Go ahead.
why is the f of 1 equals 2 like a whole circle? without
Okay.
outside.
So again, the key is this right here. So do you see here -2 is equal to?
Yeah.
So that would make it a solid dot.
Okay.
At this one right here, it's not equal to, so the last point will be open.
Oh, okay. Thank
Make
you.
sense? You're welcome.
Yep.
Thanks for asking. Okay. All right. All right, so now the third piece. Let's talk about the third piece now. All right. All right, so this time it's f of 1, which is 1, f of 2, which is 4. Now don't forget the third piece is a parabola, right? But it's not starting at 0. So here, solid dot, solid dot. So 1, 1, 2, 4. All right. Now what you're supposed to remember is this looks like a parabola. It's not a line. Save on like this. All right. Anybody have any issues with that?
How do you know it's a parabola?
Well, because comes from your information, knowing that y equals x is linear. Y equals x squared always looks like this.
Oh, okay.
And y equals the absolute value of x. Now you know it looks like a V. And in the future, you'll see all different types of graphs that you'll learn. All right. But those are pretty much the three that you're supposed to know now. Okay. Check out 9, 10, 11. All right. So f of 3, this is just making sure that you remember your order of operation. So it'd be -2, absolute value of 2, plus 3 times 3 squared, which is 9. -4 plus 27. Looks to me like 23. Anybody have any issues? All right, f of -1, here we go. -2, -1 minus 1, plus 3 times -1 squared. -2 times 2 plus 3, -4 plus 3, -1. Any issues? All right, so now f of 1/2. So now we have -2. So -2 times the absolute value of -1/2 plus 1/2 squared is 1/4. So -1 plus 3/4 equals -1/4. Anybody have any issues with that information? Just practicing order of operation. Anybody? All right. Standard form. Write the equation in standard form. So everyone wants to write down ax plus by equals c. So because we have 2 points, we also want to write it in point slope form first. And because we're missing the slope, m equals y2 minus y1 over. So here we go. M equals, now don't forget this is x1, y1. So now we have -5 minus 1 over -6 minus 3, -6 over -9. Everybody happy with the slope being 2/3? Okay, Now we're going to use point slope. Y minus 1 equals 2/3 times x minus 3. All right, now if it said write it in point slope form, we'd be done, but we're not. We're writing it in standard form. One of the rules for standard form, remember, is there's no fractions, right? So I need to get rid of that 3. So I'm going to multiply the entire equation by 3. When I do that, the left side becomes 3y minus 3. If I multiply the right side by 3, those cancel. And now we're just going to distribute the 2. Okay? And then what I want to do is put it in standard form, which means x and y is on the same y, or on the same side. But don't forget that the x has to be positive. So we're going to write this, 2x. I'm going to move the 3y over. Then I'm going to add 6 to both sides. And that's your answer. Anybody? Again, that's just super important, okay? You got to be good at writing equations of lines. Any questions so far? Yeah, I almost let you guys do this by yourself, but what I'm going to do is I'm going to just let you take the test, right? I'm going to pass that out and have you guys do it because I think this is kind of easy. All right, so here we go. So now we want something in point slope form, which is nice, all right? Because we have the point, all I need is the slope, right? Well, we want perpendicular, right? So perpendicular, you have to figure out what the slope is, and it becomes a negative reciprocal. So 2x minus 5y equals 1. Let's figure out what the slope is. So 2x minus 1 equals 5y. Y equals 2/5 x minus 1/5. Anybody have any questions? Now I need the slope of the perpendicular. And again, all you're doing to do that is to look at this and take the negative reciprocal. And here's the point we need. Now we're writing in point slope. Just to review, so I have y minus 4, negative 5/2 times x plus 2. Everybody good? All right, I'm pretty happy with that. Now the next one, of course, is parallel. All right, and slope-intercept. All right, let's not forget slope-intercept, y equals mx plus b. So I need to find the slope real quick. So if I have x plus 4y equals 11, 4y equals negative x plus 11, divide by 4, y equals negative 1/4 x plus 11/4. Now, remember, slope of the parallel would be negative 1/4, and it's passing through the point 5, negative 2. All right, now let's do y equals mx plus b. That's what we're going for. But of course, point slope y plus 2 equals negative 1/4 times x minus 5. All right, now I don't have to worry about the fraction because the slope-intercept can have a fraction. So we're just going to distribute the negative 1/4. Negative 1/4 x plus 5/4. And now we subtract 2. All right, so y equals negative 1/4 x. Remember, negative 2 is the same as negative 8/4. And then that's your answer. Anybody have any issues? All right, you guys should be great at graphing lines. All right. Now, sometimes the kids are asked to find the x-intercept and the y-intercepts. All right, so don't forget the x-intercept. All right, make yourself a note if you forgot. The x-intercept just means when y is 0, and the y-intercept just means when x is 0. All right. So to find the x-intercept, we just plug 0 in for y. So you would say 5x minus 7 times 0 equals 14. 5x equals 14. So x equals 14 over 5. So technically you could write the y or the x-intercept as that. Okay. Now to find, again, the y-intercept, we just let x equal 0. So it'd be 5 times 0 minus 7y equals 14. Negative 7y equals 14. So y equals negative 2. 0, comma, negative 2. Again, that's the y-intercept. That's the x-intercept. All right, anybody have any questions? All right, so now one of the common things you have to do is find the slope of the line. All right, giving its graph. So to me, we can just make this super easy from here to here. So the slope is equal to down 3 to the right 2. Anybody have an issue with that? So on the next one, let's look at that. And we'll say I went from this point to this point. So that means I went up 2 and 1, 2, 3, 4 to the right 5. So the slope is 2/5. Anybody have any questions with that? All right, beautiful, man. All horizontal lines have slope equal to, of course, 0. All right, remember if you have a vertical line, all right, it's no solution. All right, guys. All right, line of best fit now. So, I don't know why that blue line's there. So the line of best fit, remember, L1 and then L2. So you're gonna go to zoom, not zoom, stat. We're gonna hit the stat button. And then you hit edit. And under L1, you list the X values. And under L2, you list the Y values. All right, so I'm gonna go ahead and do that myself on my own calculator. I want everybody else to try to do it. And I'm gonna ask for the answer. All right, now remember, keep in mind, we're not doing 11 because we don't know what the Y coordinate is for 11. If you try to do that, it's gonna be a dimension mismatch error. Okay, so please don't do 11 until the very end. So we hit stat, edit, type things in. Remember, L2 is the Y values. Now, after you type all of those in, you go back to stat. And then what you want to do is you want to go over to calc. Then you want to go down to line reg, which is short for linear regression. So stat, calc, go down to, and then hit enter all the way through, and it spits out the answer. Y equals, somebody tell me the answer. Y equals what?
I got 2.864
Good, good, good.
x minus 3.44.
Yeah, I'm happy with that. Perfect. Exactly correct. If you don't know how to do that on your calculator, you're making big mistakes. All right, that's super helpful. Now I want to estimate what 11 is, so now you just put 11 right here. All right, so on your calculator, you just do 2.864 times 11 minus 3.44. And y was approximately, looks to me like 28. Of course, you can say 28.064, but again, that doesn't really matter. All right, anybody have any issues with that?
So how did you find the y?
I took this value, watch me, this 11, and I plugged it into this equation for x equals 11.
Okay.
Does that make sense?
Yeah.
All right, good. All right, now what I want to do is let's just take a look at these SAT and ACT problems now. All right, I threw a couple of these on just to keep you honest. All right, number 18. Someone tell me what the answer is to number 18.
D.
D. Yay, D is correct. All right, anybody have any issues? All right, 19, another really good SAT problem. Most kids find this really, really hard. All right, so everybody take a look at this. Everybody read it. Now, the first thing I want everybody to do is I want everybody to write x equals, x equals, x equals. Those are the x coordinates. Now, the next critical moment in this problem is this, understanding this right here. All right, now I'm going to write A down. All right. So what this means is W of 1 plus T of 1 equals 1. Now, I'm not saying that's true. I'm asking if anybody has a problem with W of 1 plus T of 1 equals 1. All right, now let's look up here. Here's W of 1. W of 1 is equal to what? Negative 1. Plus T of 1 is this guy right here. Does that equal 1? And the answer is, of course, no. So A is not the right answer. So now I want everybody to write down W of 2 plus T of 2. Does that equal 2? All right, someone tell me what W of 2 is. What's W of 2?
3.
3. Thank you. What's T of 2?
Negative 1.
Beautiful. Does that equal 2?
Yes.
Yes.
Yes. All right. So listen to me, guys. I cannot emphasize to you enough how important functional notation is. All right. Now I need somebody to speak up if they're not understanding what I'm saying there. And there's no way mathematically to do that. You just have to guess and check your way through it.
I'm having a hard, like, I don't get how you got
3.
yeah, 3 plus negative 1 equals 2.
So W of 2. You see the purple I'm highlighting right now?
Yes.
All right. So this is the purple. This is the purple that I'm interested in right here.
Okay.
Okay. So what I'm going to do is I'm going to erase this right here. All right. And then I'm going to show you. Okay. So what they're asking is W of 2. So W of 2 means when x equals 2, y is what? So here's x equals 2. Here's the y value. If somebody says t of 2, that again means when x is 2, what's that y value?
Negative 1.
Right. There you go, kiddo. And that's where the negative 1 comes from. And that's where the 3 comes from. Is that better?
Yeah.
All right, great. Okay, 3 more SAT problems. All right. Actually, I think this was from an ACT test. No, it's SAT. All right, so here we go. I'm going to blow it up a little bit to make sure we're good. So in 1919, A.S. Reed and R.H. Holland published a paper on the growth of sunflowers. Included in the paper were the table of graph above, which show the height h in centimeters of sunflowers t days after the sunflower begins to grow. Over which of the following time periods, all right, now everybody needs to highlight this. Average growth rate. The average growth rate means slope. Everybody needs to do that. The average growth rate is slope. So now I'm going to look from 0 to 21. I'm going to highlight that. From 0 to 21. And then from 21 to 42. Wait a minute. That's not 0 to 21. So 0 to 21 would be here. And then from 21 to 42 would be here. And then 42 to 63 would be here. And then from 63 to 84 would be here. So the question is, which one has the greatest slope? Which one is the greatest slope? Now, again, might be easier if I did a skinnier line. Let me do this. All right, just to make sure. So from 0 to 21, we're going from there to there. And then from 21 to 42, which one is greater so far? Which one has a bigger slope? The first one or the second one? Somebody.
First one.
Second.
Now look right here, guys. Here's a line. What's that slope right there?
0.
0.
It's getting, the slope is getting bigger. Does everybody see that? And now it's undefined. Okay. So this is the measurement for 0, and then it's getting bigger, right? So now let's look at it one more time. From here to here, compared to here to here. Hopefully I did a good job now and you understand that from here to here has the greatest slope, right? Oh, but it wants the least anyway. Man, I'm just not reading properly. So which one is the least, not the greatest? Which one's
D.
Yeah, D is the smallest. I can't read very good. All right, so again, I don't want to confuse anybody, so make sure you're understanding me. Average growth rate is just a slope. So obviously, the slope at the very end is the smallest. Everybody good with that? Okay, let's look at 21. The function h defined by h of t equals blah, 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 where a and b are constants, models the height of the sunflower after t days of growth during the time period in which the growth is approximately linear. What does a represent? Okay, now what I want everybody to do is does everybody understand that's the A, right? Is everybody with me? All right, I don't feel like I'm just talking, so I want to make sure these are the ones that are important. What does A represent? Does everybody see my A and A in reference to the line, right?
Yes.
So
Yes.
A, thank you guys. A is the slope, right? Because this is linear, okay? Now the slope is, don't forget, the change in y over the change in x. So over here, the y value is what? Height. So that would be the change in height over the change in what? Time. Right? So let's read them. The predicted numbers of centimeters of sunflower grows each day during that period. Well, it is the change in height, which is how much it grows each day. That's what the change in time is, days. So let's go ahead and I think it's A. All right, but let's look at B. The predicted height in centimeters of the sunflower. All right, well, predicted height is not a change, so I know it's not B. The predicted height in centimeters of the sunflower at the end of the period. That's not a change, okay? The predicted total increase in the height of the sunflower in centimeters during that period, all right? Now, D and A looked pretty close, but let me explain to you why it's A. Because your slope, right, is the change in height per day, all right? That's what that's referring to. The change in height per day. That's what that means. So the mistake here was when it says during the period. It's not during the period. The period is every 1 day. All right. So that's why the answer was not D and A. All right. So again, 21 was kind of tricky. So I'm glad we went through that one. All right. I think this is the last one. Okay. So now here we go. All right. It says the growth rate of the sunflower from day 14 to day 35 is nearly constant. On this interval, which of the following equation best models the height? Right, so this right here is what they're asking for. They're asking for the slope. Notice all the slopes are different. So what I want to do is we're going to figure out what the slope is from day 14 to day 35. So we have to look at this model right here. This is day 14 and this is day 35. All right, so you need your calculator here to figure out what the slope is. So slope is 131 minus 36.36 over the two x values, which is 35 minus 14. Now I need some help with that. Somebody tell me what the slope is or what you guys got.
I got 4.5.
Anybody else get 4.5?
That's what I got too.
All right. So now I'm looking back. The only one that has a slope of what? 4.5. There we have it. Is B. All right. Anybody have any questions? I think that's it. All right. So now let me try to explain. I'm going to go ahead and pass out the test. And I really just kind of want you guys to do it and get it turned in. You have whatever, a couple days to do it. Right now, listen to me, guys. I'm trying to tell you, I'm not interested in the grade. Right, I'm interested in you telling me what you know and what you don't know. Because some of you are going to be taking entrance exams and you're going to be taking tests to see what class you're in. And all of this information, I promise, that's why I do this, is on there. All right, all the information. So again, I'm trying to make sure everybody's learning the material, whether you're going to IB, whether you're going to Jesuit, Tampa Prep, Berkeley, Academy of Holy Names. They're all going to give you standardized tests. You have to know the information. So if I'm not clear, this especially, this lesson on lines is super duper important. All right. So again, I think the test has 20 questions kind of like it too, so it won't take you that long to do it. All right, I don't mind if you even use your notes to kind of look things up, but you got to evaluate yourself and make sure, you know, if you're not understanding something, you got to let me know. All right, does anybody have any questions? All right, it's going to take me like probably 5 minutes to post the test, and I want you guys to turn it in. All right, next class period. Anybody have any questions?
Mr. Stroud, do you mind if we work together?
No, you know what? That's a very good question. And part of the reason why I don't care is, because your grade is not important to me. I care whether or not you know the material. So if you're just not understanding something, I'd prefer you ask me. But if you're asking someone to honestly try to understand the material, that's my objective. That's what smart people do. All right.
Okay.
So the question or the answer is no, I really don't care. Right. But if you have no idea, I don't just want you writing down an answer just to say you got the work done. All right. I don't care about the work. I care about you being a good student. All right. Anybody have any other questions? That was a good question.
Should we turn this worksheet in?
No, don't even bother turning it in because I did the whole thing. All right. I don't care. It's a waste of my time to put a grade on all of them. Okay. I don't want to do that. It takes me forever to grade a quiz or a test because I have to look at everything. All right. So do me a favor. Don't worry about turning it in. Just make sure you understand it. And like I said, it shouldn't take me long to post the chapter 2 test. And you guys just work on that. And you have, till the next class period. And the reason why I want to do that is because I don't want to waste a whole class period. Like chapter 3 is, I think, all the polynomial stuff that's critical review, factoring, adding, subtracting, dividing, all that stuff, which is easy. All right. But still, all right, needs to be reviewed. So if you don't have any other questions, you can just kind of log off and give me 5 minutes and I'll add that on. All right. But I appreciate you guys. Hopefully you guys are staying safe and healthy.
Thank you, Mr. Stroud.
You guys have a great day, okay? Work hard. Let me know if there's problems.
Bye, Mr. Straw.
Take care, guys. Take care.
Thank you.
You're very welcome.
And so, like, the